Hey friends, this is Physics Boy, and now it's time for Banking Off-Road Part 2. Earlier, on a level curved road, force of friction was responsible for creating centripetal force, but it will be better to raise the outer edge above the inner edge. So a component of normal reaction would also contribute in providing necessary centripetal force. Let's talk about the forces acting on the car. Here we can clearly see that weight of the car mg acting vertically downward and normal reaction are acting perpendicular to the surface. Also there's force of friction acting along the surface. The normal reaction can be resolved into two rectangular components. This resolving of the rectangular components is very simple to understand as this is acting perpendicular to the surface. So there is some amount balancing the vertically downward force mg, that is r cos theta, and towards the center of the curve there's a component of the of the normal reaction acting r sin theta. Force of friction can also be resolved as shown. This is f cos theta acting along the curve towards the center of the curve, and f sine theta towards the weight of the car towards mg. And we can also see that these forces balance each other in total, as r cos theta is acting vertically upward and it is balanced by f sine theta plus mg, weight of the object, and there is nothing to balance r sine theta, that is normal component of normal, and f cos theta, that is acting towards the center of the curve. So these two forces in total contribute towards the centripetal force which is required to move along the curve. So writing down these things, r cos theta is equal to mg plus f sine theta, and r sine theta plus f cos theta is equal to mv square, providing the necessary centripetal force. We can write F is equal to mu s r, as we know mu is coefficient of static friction, and here we are talking about static friction where the object is about to move outside the curve, that is before sliding off. In case we talk about safe speed, it must not slide. So here we consider coefficient of static friction, and putting F is equal to mu s r in our further equations, and moving ahead, putting fs is equal to mu s r in our equation 1, we get r cos theta is equal to mg plus mu s r sin theta, and shifting towards the left side, taking r common, we get r is equal to mg upon cos theta minus mu s. Putting the value in equation 2, we get r sin theta plus mu s cos theta is equal to mv square upon r. So here putting the value of r that we have find mg upon cos theta minus mu s, putting the value here, cut off m, we get v square, putting r and here g, rg into, and taking cos theta common. This is a very usual step we carry out while solving trigonometric equations, and following this we get tan theta plus mu s, because sin theta upon cos theta is equal to tan theta, and here cos theta is common, and further similar we get tan theta here, and this is the equation for the maximum safe speed. So friends, this was the easiest possible explanation for the safe speed on a banked road. And if you like the video, please like, subscribe and share. Thanks a lot.